Hello all, welcome to EC Electronics. So in this video we are going to see about energy meters. We'll be seeing the basics of energy meters and also we'll be discussing about the single phase energy meter and the three phase energy meter. Both the devices, circuit and also working. Okay, so we'll be discussing about the energy meters in this video. I'm really hoping that you'll be finding the video useful, and if yes, please don't forget to like, share and subscribe. Now let's see about energy meters. In today's video, we are going to discuss about energy meters. Okay, so we have discussed about analog type of voltmeters, ammeters and some other meters, right? Now, just like the voltmeter measures voltage, ammeter measures current, energy meters are devices which is used for measuring of energy. That is how much energy is consumed. And this energy which we are measuring, we'll be calculating in terms of how much power is consumed in how much time. So we are going to measure the power and the time, and they are being combined or integrated to get the energy value. Okay, so in general we can say that the energy meters are used for measuring of energy, and they are also called watt-hour meters. Okay, I hope that you have heard about the terms energy meters because and watt-hour meters, because we use these energy meters at our home itself, and also in various other areas wherever we use energies. Generally we use energy meters to record its consumption. Okay, so here it is also called as watt-hour meter. Why? Because these meters measure power and also they calculate the time. So it is power unit is watt and time unit is hour. So it is watt-hour meter, and integrating the power and the time will get the energy value. Okay, and also I hope that you know we tell the energy measurement or the energy values in terms of unit. 1 unit of energy or this much unit of energy has been consumed, right? So this unit, how can we define 1 unit of energy? 1 unit of, we say 1 unit of energy as 1 kilowatt of power in 1 hour. That is, if 1 kilowatt power is consumed in 1 hour, that is 10 raised to 3 watts of power. If it is consumed in 1 hour, we say that 1 unit of energy is being consumed or 1 unit of energy is being used. Okay, so this is how we define the energy values as units, energy units. Okay, now we are going to mainly see in this video about the two type of energy meters, which is single phase energy meter and three phase energy meter. I hope that you know there is single phase lines and three phase line. For higher end devices like AC air conditioners and various other high load devices, we use a three phase connection, right? There are 3 wires or 3 phase connection is there, and there is single phase connection also for lower power consumption or lower energy consumption devices. At home itself, we connect in 2 different ways, right? For higher end devices, we use 3-phase supply, and for the lower end devices, we connect only single phase. That is the common practice. Okay, so here we are going to see what is the 2 type of energy meters, which is single phase energy meter and 3-phase energy meter. Generally, at our home, we have the single phase energy meters, and in the higher end consumption areas like in some industries, or if the power consumption or the energy consumption is so high, we go for the 3-phase energy meters in general. Okay, so the main difference is that for a single phase energy meter, it can be directly connected in between the line and the load. Okay, and a single phase supply is connected to it, whereas for a 3-phase energy meter, a 3-phase supply, there will be 3 lines attached to the meter. Okay, so that is the main difference or main classification of energy meters: single phase energy meter and 3-phase energy meter. And there are also other type of classifications like analog and digital energy meter, and various other classifications are there, but the main one is single phase and 3-phase. We'll be seeing the diagrams and working of both the single phase and 3-phase energy meters in this video. So next we are going to see about the single phase energy meter, its diagram and working. After that, we'll be seeing the 3-phase energy meter, and also we'll be discussing some important questions connected with this topic. Okay, so the diagram drawn here is a diagram of single phase energy meter. So this is actually an old fashioned type. Nowadays, this type of energy meters are not used. Electronic type of meters are used. Okay. So here, this energy meter is an aluminum disc type energy meter. Here there is an aluminum disc in this device which is rotating and whose speed of rotation is actually directly proportional to the power consumed. Okay, and hence we measure the power measurement and we also record the time, and the time and power we use, that is its calculations or its readings we use for calculating the energy. Okay, so that is the simple method which is used in the aluminum disc type energy meters. Okay, the principle of operation of this type of energy meters is that the speed of rotation here of the disc, speed of rotation is directly proportional to the power. Okay, so there is an aluminum disc whose speed of rotation is directly proportional to the power, and we connect some pointers or reading instruments along with the shaft to which this aluminum disc is connected, and when this pointer, when it moves, we get the corresponding power measurement. Okay, so here in this diagram what all things are present, let's see. So there are three type of magnets present here. There are series magnets, there is shunt magnets in the upper section, and there is also a brake magnet. Okay, and there are two sets of coils. There is current coils connected along with the series magnet, and there is pressure coils connected with the shunt magnets. And also you can see that these series or the current coils are in series with that of the line, whereas the shunt magnets and the pressure coil are connected as parallel with the line. Okay, so the series magnet is in series with the line, whereas a shunt magnet is in parallel with the line. Okay, also there is a brake magnet. This brake magnet, its purpose is to actually oppose the movement of this aluminum disc. Okay, so when the aluminum disc is moving and when there is no measurement happening, its purpose is to bring back the aluminum disc back to the normal position or the initial or the ideal position. Okay, so the brake magnet will actually try to oppose the movement of the aluminum disc. Okay, also you can see that there are two type of coils here, which is current coils which is connected to the series magnets and pressure coils connected to the shunt magnets. The number of turns of the, see here, this is the pressure coils, these are current coils, and the number of turns of pressure coil, you can clearly see it is more than that of the current coils. Number of turns of pressure coils greater than number of turns of current coils. Okay, so now let's see how we calculate the power here. We know that power P equal to V into I. So if we get the voltage reading and the current reading, we can calculate the power, right? And for that purpose, we make use of the flux associated with the magnets. There is series magnet and there is shunt magnet. The series magnet produces a flux. When this single phase AC supply is connected, these coils are inductive coils, right? So when a alternating supply is given to the coils, it will generate some flux, right? So when the supply is connected to these coils, these two coils, that is the pressure, that is the current coils and also the pressure coils, will generate some flux. And also there is magnets, they also generate some flux around it. Okay, so the flux generated in this in this series magnet is proportional to the current. So that's why we call this as current coils. See here, in this session we make measurement of the current. In the top session we utilize the magnet and the coils for measuring of the voltage, and when we get the voltage and the current values, we'll get the power. Okay, so the series magnet produces a flux which is proportional to the current, and the shunt magnet produces a flux which is proportional to the voltage. And these two flux, okay, so there is a flux generated in this region, in these coils, and also here. So these two flux are 90-degree lagging in nature. They are opposing in nature. Okay, so when they interact, what happens? Eddy currents are generated. So the flux in this region and this region, when they interact, see here, there are two flux generated here. Here the flux generated is proportional to current. Here the flux generated is proportional to voltage. Okay, so these two flux are opposing in nature or 90-degree lagging. When they interact, okay, what happens? Some eddy current is generated, and this eddy current will move the disc which is placed in between these two sections. Okay, so that's how this aluminum disc will actually rotate due to this formation of eddy currents. And in turn, this disc is connected to a pointer with a scale reading for power measurement. So this pointer will move as this disc is rotating, and which will give the corresponding power. Okay, so that is the working of this single phase energy meter. I'll try to explain it once again. See here, there are two sets of magnets and it is connected to the current coils, and this region will give us the flux which is proportional to the current, and here there is parallel magnet or shunt magnets and pressure coils. From this region we will get a flux proportional to the voltage. Okay, so when these two flux interact, eddy currents are generated which will rotate the aluminum disc. The aluminum disc is connected to some pointers, and this pointer will indicate the corresponding power. Okay, so that is the working of a single phase energy meter. Okay, now let us see how a three-phase energy meter is looking like. So next we are going to see about the three-phase energy meters. So the three-phase energy meter is used for measuring the power of a three-phase supply. Okay, so the three-phase energy meter is constructed by connecting two single-phase meters through a common shaft. So through a common shaft, two single-phase meters, one at the top and one at the bottom. You can see two single-phase meters are connected together, and hence we get a three-phase meter. Okay, so there are three lines which is connected with this meter or this device. Okay, so and the total energy, how we calculate is, we take the sum of the reading of both these elements, and hence we'll get the total energy. Okay, so the total energy we take by summing the two elements. Okay, here also you can see there are current coils and there is pressure coils for each device. There is one single phase meter here, just like the previous part we have discussed about single phase meter. In that we have discussed that there is current coils and pressure coils. Just like that, here also two identical devices are used. There are current coils, there are pressure coils. The number of turns of pressure coils is greater than the current coils. And here also the same, pressure coils and current coils are there. And the connection of these, the current coils is series with the line and the pressure coils are connected as parallel with the line. Okay. Now, the three-phase meter has also two discs mounted onto the common shaft. You can see there are two aluminum discs, right? Both the discs also has a brake magnets. See there. This brake magnet, just like for the previous case I've explained, that it is used for bringing back the disc to the initial state or the normal state when it is not taking any readings. Okay. So that is the purpose of a brake magnet. And along with that, there will be, even though it is not shown in this diagram, there will be copper rings and shading magnets and compensators. Okay, so these two elements will, as a combined form, will give us the total energy. Just as for the single phase device, there are current coils and also current coils here. So these current coils will give us the current value, or the flux associated with it will be proportional to the current. And the pressure coils you can see in the top and the bottom. So this pressure coils or the flux associated with it will be proportional to the voltage. Okay, so these two flux will interact and will produce some eddy currents, and the two aluminum discs will rotate, and they are connected to some pointers, and hence we'll get the power reading, right? And we take the sum of both the elements and we'll get a total power, and we'll calculate the total time period. And on integrating, that is, we know that energy is equal to integration of power into dt. So power and time, if we get, you can find the energy value, and hence we'll get the total energy consumption. Okay, so the only difference of a single phase energy meter from a three phase is that for a single phase there is only one there is a single phase meter, but for a three phase energy meter you have to use two single phase meters. Okay, so that is the difference. The reading and everything is same. Here we have to combine the values of or the readings of two elements, two single phase meters, and only then we'll get the total power, right? Okay, so that is the difference. So that is all about the structure and the working of a three phase energy meter. So the major difference is that we use single phase meters along with single phase supply. Here three phase meter we use with three phase supply, or for measuring the power of three phase line we use a three phase energy meter. Okay, now let us see some important questions connected with this energy meter area. Next we are going to see some important questions connected with the energy meter area. Okay, so the first question is, an electronic energy meter make use of dash. Okay, so the electronic energy meter make use of ICs for measuring the energy. So in this video we have discussed about the aluminum disc type or the rotating disc type of energy meters, but nowadays these disc type meters are being replaced with the electronic energy meters where we make use of ICs. Okay, and they are more accurate. Okay, so it make use of ICs. Then the measurement of energy involves dash. So we have discussed in the video that energy is measured in terms of power and time. So the measurement of energy involves power consumption and time duration. That is measuring of power consumption and time duration. So power, time. Both these things we measure and then we calculate the energy. Third one is a very important question. What is creeping in energy meters? So in energy meters, when the magnetic circuit is asymmetrical, so we have discussed about the inductive type or the aluminum disc type of energy meters, right? So there the major role is for the magnetic field and the magnetic flux, and due to its interaction actually the disc is rotating. Okay, so when the magnetic circuit is asymmetrical, a driving torque is produced, and as a result due to this driving torque, the meter will produce some effect called creeping. Okay, so why this creeping is happening, or why we call it as creeping? Because even when no load is attached, due to a very small voltage in the pressure coil, the disc will start to rotate. Okay, that is, there won't be any current in the current coil. There are two coils, right? There are pressure coils which will give us the voltage, and there are current coils which will give us the current, right? So even though there is no current in the current coil, only there is some voltage due to some error. If some voltage is coming in the pressure coil, even if there is no load connected, there will be rotation of the disc happening. Okay, so this disc rotation is actually due to some asymmetrical alignment of the magnetic circuit, due to which a voltage is generated, due to which the disc is rotating, and this effect is called creeping. Okay, so this is an undesired or an unwanted thing. We don't want the disc to rotate when we are not making the measurement. We want the disc to rotate only when we make the measurement, right? So this is called creeping effect. Now how to avoid the creeping effect? There are several methods. One method is to make a hole in the disc. Okay, not just one hole, we make identical holes at the two ends of the disc. Okay, and this holes made will help to prevent the unwanted rotating of the disc. And sometimes there is another method, attaching of small iron pieces, okay, at the edges of the disc. Iron pieces. So this iron piece will interact with the brake magnet and this brake magnet will try to prevent the unwanted rotations. Okay, so there are several methods. There are making of holes in the disc, or there can be usage of iron pieces. These iron pieces will attract the brake magnet. Okay, that is, they will interact with the magnetic field of the brake magnet and they will try to prevent the disc from rotating. We know that the purpose of brake magnet is to prevent the disc from unwanted rotations. Okay, so that is happening with the help of the iron piece. It will be more pronounced. Okay, so these type of methods can be used to avoid creeping. Next question, what is the advantage of electronic energy meters? So we have discussed about the rotating type of energy meters, whereas in electronic energy meters, there is no disc, or there is no rotating, there is no creeping, there is no frictional effects, and they are more accurate. Since we are using some IC, electronic means we will be using some ICs, right? So when we are using some ICs or from some other devices other than this rotating disc, it will be more accurate. Why? Because they are having no creeping effects in general, and also they don't have frictional losses, right? So these type of problems are not there in this electronic energy meters. Okay, so that is the main advantage of having electronic energy meters. And nowadays this type of energy meters in all houses, we cannot see in the old houses. We can see that there will be some disc type of meter in front of the house or in the side of the house, and we can always see the disc is rotating. Sometimes it will be very fast, sometimes it will be slow. I hope you have seen, because at my home I have seen. So these technologies are being changed or updated with the help of new technologies, especially when due to this electronic new devices are coming into the market. So these old devices are being replaced with the new ICs and components. Okay, so nowadays you cannot see any rotating disc type of meter. They are being replaced with the electronic energy meters. Okay, so in this video we have discussed mainly about the single phase and the three phase energy meters. So I would like to brief up this session with the key points. The first one was, what is an energy meter? It is used for measuring of energy. Energy is measured in terms of power and time. So we'll take the total power consumption of the devices and we'll calculate the time, and hence we'll get the total energy consumed. And one unit of energy also we have defined. We have not defined, we have discussed what is 1 unit of energy. 1 unit of energy is equal to 1 kilowatt of power in 1 hour. In 1 hour duration, it is called 1 unit of energy. And also we have discussed about single phase energy meters and three phase. So single phase energy meters are generally used for low power consuming devices, or generally for household, that is in homes, we mount single phase meters. But when we go for higher end power consumption areas like industries, we make use of three phase energy meters. Okay, so single phase energy meters are used for measuring the energy in single phase lines, whereas three phase energy meters used for measuring the power consumption in the three phase lines. Okay, so in single phase energy meter we have seen that there are two type of coils are there. Pressure coils is there, current coils is there, and three type of magnets: series magnet, shunt magnet, and brake magnet. And also there is a aluminum disc which will be rotating, and due to this rotation, its rotation is directly proportional to the power consumption, and we take the power from it and we take the total time, and hence we'll calculate the energy. When coming to the three phase energy meters, the only difference is that in place of one single phase energy meter we use two, and we take the reading from both the single phase energy meters and we sum up and we'll get the total power. Okay, so that is the difference between single phase and three phase. So we have seen the diagram and the working in detail. I'm really hoping that you found the video useful. If you are preparing for some examinations, especially, this video will be a quick revision of these two energy meters. Okay, so I'm really hoping that you found the video useful. If yes, please do give it a thumbs up and also share it with your friends. And if you want more videos, please do subscribe to the channel. Thanks for watching and keep on watching.